Welcome to HB Tuner's Ford Gen 2 Coyote Training, Part 30. This training module we're going to be exploring working with our driver demand table to shape our drive-by-wire throttle response. We have a lot to cover. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at how we can control our drive-by-wire throttle response within our programming on our Gen 2 applications. This tutorial, I'm going to go after trying to make my pedal plate relationship a more linear fashion. This is going to give me more control over the dynamics of my vehicle, and in mid-corner, I like to road race the Mustang, and I like to make sure that I have proper pedal plate relationship so I have a more predictive type of control over the car. I know mid-corner that if I push the Excel pedal a little bit, I'm not going to have a huge change in my throttle plate, allowing a whole bunch more torque to be made out of the engine and unsettling the car. This is dangerous in a corner, and it's also hard to drive the car fast. So I'm going to go through and change a few things so you can see how you can manipulate the relationship between your pedal and your plate. Now, namely, we're going to be editing our driver demand table, changing some of our torque values in our table, but we're going to have to take things typically a step further in order to get even further control over our pedal plate relationship. That's typically not going to be enough, and I'll explain and show why that's going to be here with some data log examples. We're going to be flashing the car, driving here on the chassis dyno so you can actually see what this is going to look like. The very first thing I want to do for this tutorial is jump in and take a look at our driver demand table and talk about a few things. Then we'll move into the VCM scanner, and we're going to take a look at a stock drive-by-wire throttle mapping in terms of the driver demand and how that's going to look in terms of some of the control aspects. I'm also going to be pointing out something that we can disable that's going to give us better control over our throttle and actually have less throttle plate movement as we're driving around. It actually improve the drivability. I like to always disable it because typically it's going to create problems for us. So we'll talk about that here in a few minutes. Let's jump in and take a look at our driver demand table. The calibration file we are working with, I've labeled it here drive-by-wire response tuning. This is going to be the torque-based tuning calibration that we worked with in the last few tutorials. I'm just naming a new name here and starting off with that from this point. Now, I do want to mention I haven't changed the driver demand table values. They're all going to be stock from Ford. So we'll look at how we can program this to follow suit so we can make our pedal plate relationship exactly how we'd like. So let's jump in here and take a look at where we can find the driver demand table. So going up here under our engine tab, and we're going to move across from general over here into torque management. Under the driver demand tab, we find here an automatic transmission equipped vehicle that I have and I'm working with for our demonstration vehicle. We're going to find we have a normal table, a crankshaft compensation, and then a pedal map ratio. You'll find if you have a stick shift Gen 2, there's going to be a little bit different tables. Specifically under your normal engine table here, you're going to have one that's going to be for reverse, park, neutral, first gear, then second gear, third gear, fourth gear, fifth gear, sixth gear. You can actually change your torque relationship, your pedal torque relationship, to be able to essentially drive your throttle plate differently per gear in a manual transmission car. When we're talking about an automatic transmission, things are a little bit different. So let's go in and take a look at this real quick, and let's see a few things within our table here. So we'll go into our normal table. Now this table is based on our Excel pedal position. That's what we put our foot on in the vehicle. That's our traditional gas pedal in any vehicle. Now in this case, it's electronic, and our pedal and our plate aren't directly mechanically linked as we'd find with a traditional throttle cable. So we're under this virtual type of control, and we can control how that relationship's going to go through this programming. So the Excel pedal position here is going to be that throttle that we put our foot on in the vehicle from 2% all the way up here to 83.3% in our pedal position movement. It's also driven off of engine speed, and if we take a look at the values in the table, this is going to be known as our net torque, or the actual engine flywheel torque. When we're talking about our torque tables, those are going to be called scheduled or indicated torque. Those are less frictional losses. These values in here are going to be our indicated or scheduled torque minus frictional losses for a true net torque, or flywheel torque, as we would speak in terms of flywheel or wheel power. This would be flywheel power, or what's outputting from the engine going into the transmission and the drivetrain assembly. So We can see here at any given accel pedal position, we'll have a certain amount of torque that we're requesting. Now this is essentially driving our drive-by-wire throttle control system. So we're seeing here as we feed more and more pedal input, we have our torque value starting to increase.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.